In this video, we will continue to practice our angle and arc relationships in lots of different situations. And just real quick, remember, it all depends on the location of the vertex with respect to the circle. If the vertex of the angle is at the center, then the angle and the arc are the same. If the vertex is on the circle, like on the edge of the circle, then the angle is half the arc. Okay, which means for example, if the arc was 80, then the angle would be 40. But of course, that means that the arc is also double the angle. So we could say the arc is double the angle would be like another way of writing it. Anyway, if the vertex is inside the circle, we have to use both intercepted arcs. This makes sort of an hourglass shape, or like a bow tie, I guess, when it's sideways like this. And use that bow tie image to make sure you're looking at the right arcs. And the angle will be arc plus arc divided by 2. And finally, if the vertex is outside the circle, again, we have the two arcs. It has to be the two arcs inside the angle. And the angle will equal the big arc minus the small arc divided by 2. Also, if you have a quadrilateral inscribed in a circle with all the corners touching, the opposite angles are supplementary. So they have to add up to 180. Keep that in mind going forward. So looking at problem number 7, we notice that the angle is outside of the circle. So the relationship here was that the angle is equal to the big arc minus the small arc divided by 2. Okay, that was the formula. Let's see. So the angle is right here. I'm going to go ahead and call that x. Okay. Now look, when we talk about the big arc and the small arc here, we've got the small arc is the 96. All right, that's right here. But what about the big arc? Like, where is it? What is it? Okay, so here's the other arc that's intercepted, is I'm showing here in green. All right, they did not give us a number for that, though, so what do? Well, the green is the rest of the entire circle. The green and the red together make up the whole circle, total of 360. So I should be able to simply subtract from 360. So if I go 360 minus that 96, that gives me 264. So I've got 264. And that's how you do it. So now I can go ahead and use the formula. So angle equals, so that means I'm going to start off with x because that's the angle. And then arc plus arc, big arc minus the small arc divided by 2. So that's going to be 264 minus 96 divided by 2. Okay, so it's 264 minus 96 divided by 2. So that's 84. All right, now let's see what we were actually asked. The measure of arc DBC. All right, DBC, that's the green arc. We found that to be 264 degrees, and the measure of angle G was 84 degrees. Okay, moving on to number 8. Well, this vertex is inside the circle, and the relationship there was angle is equal to arc plus arc divided by 2. So look for the hourglass when you do this, you guys. So I see that 76-degree angle, so I'm going to sort of build my hourglass around that angle. All right, so that means the arcs that we need are the ends of the hourglass, or the bow tie, depending on how you look at it. Okay, so I'm going to put an X right here for right now, because that's, when we talk about angle is equal to arc plus arc divided by 2, the angle is given, one of the arcs is given, so this is the other arc, so that's what I can find. So let's go ahead and set it on up. Again, be careful. Angle equals. The first thing you always put is the angle. So a common mistake is for a student to put X right here. X is not an angle. X is one of the arcs. So since the angle is 76, then that's what I have to start with. So I have to start with 76 equals, angle equals. Now arc plus arc, that's X plus 59. Those are the two arcs. Okay, divided by 2. Then it's just a matter of how do I solve an equation like this. And the easiest thing to do is just to multiply both sides by the denominator. That way these 2's will cancel each other out. All right, so that's 152. So we have 152 is equal to X plus 59, and then you just subtract 59 from both sides, of course. So that's 93. Okay, great. Now let's see what they asked us for. See if we have it or not. All right, so they asked us to find the measure of arc EF. And that is the X that we found, so that's great. That is 93 degrees. But they also asked us for the measure of arc ED. Okay, so in addition to what we've already found, they're asking us to find this green arc. Okay, well, yeah, that's fine, because this is a diameter. I always like this to be turquoise for some reason. Okay, that's my diameter. That means I have a semicircle going on up top. These have to add up to 180. So if I subtract 180 minus the 59 there, that leaves 121 for this green arc. Did I say 121? Yes. So that's what I have. So that's why this is 121 degrees. All right, moving on to number 9. Okay, all right, it looks like we have a combo situation. Okay, maybe I can sort of color code this a little bit. Let's see, so one thing that we have this angle right here. Okay, and that goes with this arc right here, all right? So that all kind of goes together. This angle that I just drew is on the circle. So the formula there is that the angle is equal to the arc divided by 2. So that's why if I take half of 64, I'm going to get 32. So that angle right there is going to be 32. Okay, all right, so I'm going to come back to that. Okay, let me squeeze this more up into the corner. So this is 32. On the other hand, we have another angle. I see this arc over here. Okay, I'm switching colors on it. So this arc goes with this angle right here. All right, notice that this is not 90. Some kids just assume if anything looks remotely like a right angle, they just assume. But this angle is at the center. And when you're dealing with the center, a central angle, the angle and the arc are the same. So that's why this should be 88. So I'm actually going to erase this first. Get it out of my way. So this is 88 right there. Okay, now, going back to that other triangle for a second, I'm going to go ahead and look at this as a triangle with me. Okay, so, you know what, let me start with this. Okay, right away you should know what angle E is. All right, and the reason why you know what angle E is because the angle E is on the circle. All right, that means the angle is half the arc. What's the intercepted arc? It's this. Okay, how big is that arc I just drew? That's 180, right? Because this is a semicircle. See the diameter? So half of 180 is 90. So right away, you should know that this is a 90-degree angle because it's half of a semicircle. Okay, so now that we have that, then if I look at this as a triangle, like let me go ahead and draw the third side, then what I realize is I have 2 out of 3 angles of a triangle. So I should be able to find the third angle very easily. All right, I could either subtract the 2 angles that I know from 180, so 180 minus 90 minus 32, that's 58, so I know it's going to be 58. Or automatically I know that if one angle is 90, that means the other 2 angles have to add up to 90. So usually I don't go all the way back to 180. Usually if I have a right triangle and I'm missing an angle, I just go 90 minus 32. Whoops. Okay, which is 58. Okay, now I'm trying to find like everything I can, just because that's a good thing to do. All right, these pictures are the same. Okay, so I'm gonna just fill in some more stuff here. So since this is a semicircle over here, right? See the semicircle? Then these 2 arcs have to add up to 180. Okay, so if this is 88 right there, then that means that this must be 92. Okay, and since this is a central angle, that should be the same. So if this is 92, that means this is 92 right here. Also, linear pair is happening. They have to add up to 180 as well. Okay, and now looking over here to the left, we have one more semicircle happening over here. Okay, so that means that this has to add up to 180, which means that this arc right here, I should be able to find it by subtracting 64 from 180. So that's 116. All right, now I really found everything in the picture. I guess I didn't find these little angles up here, which I could have. Let's wait and see. If they make me go back and find these, like the angle up here and the angle down here, I can. But I'm not going to do it if they don't ask me to. So the measure of angle E we know to be 90. Okay, boom. The measure of angle B, that's 58 degrees. The measure of angle BAC. Okay, BAC is that angle right there. That is 92. Okay, how about the measure of angle BDC? All right, BDC. Ah, okay. All right, that is one of those angles that I didn't find yet. So I guess I am going to have to do it. I think I will do this on the other picture, which is less cluttered. So guys, focus your eyes on this triangle right here. All right, I've got this triangle happening. Okay, so here's the key. The key is recognizing that this is an isosceles triangle. All right, this is a circle. So if I look at this right here, I'm going to change the color a little. All right, do you understand that this is the radius of a circle? Okay, now this one over here, do you understand that this is also the radius of the same circle? All right, the circle is going to be the same size in every direction. That's what the definition of a circle is, equally distant from the center. So since these are both radii, that means that this and this are the same. So that makes this an isosceles triangle. Okay, now, one thing you need to know about an isosceles triangle is that the base angles are equal. So like this angle right here and this angle right here, because of symmetry, these are going to be equal. They're going to be congruent. And we previously found, or we can see that this is 88 right here. Okay, so I can find these other two congruent angles. Because they are congruent, all I need is one angle and I can find the other two. A triangle in full starts out at 180 degrees. Okay, so far we've used up 88 degrees. So if I subtract 88 degrees, then that leaves me with 92 degrees. All right, so that means I have 92 degrees left over to be shared between this angle right here and this angle right here. Now, it's got to be shared equally because they are congruent. So therefore, what am I going to do? Of course, I'm going to divide by 2. That's how you share equally, you divide. So that's why I'm going to be doing 92 divided by 2. Okay, and that is 46. So that means that these two angles must be 46 and 46. And if you went back and added up these three angles, you would get 180, and it all makes sense. So anyway, they asked us to find this angle ADC. That's 46. I'm sorry, they called it BDC. Same thing. All right, BDC is this angle up here. That's 46. Number 10, on which of these diagrams can we tell that arc BC is 100 degrees? Circle all that apply. Well, in the first picture, the vertex is on the circle. That means the angle is half the arc. The arc is double the angle. So this is the intercepted arc. So that's going to be 100. So let's circle that one. On this picture, we have a central angle, so the angles and arcs are the same. So if this arc is 100, that means that the angle right here is 100. Vertical angles are congruent, so that's 100. And then that's going to match the intercepted arc. So BC is 100. Let's circle that one. And this is just a straightforward central angle. That's 100. They just straight out gave it to us. So BC is 100. They're going to match. Okay, and here we have another inscribed angle, another angle that's on the circle. So the angle is half the arc. Actually, that doesn't even matter. What matters is that we have a diameter here. Okay, that means this is a semicircle over here. All right, this is a semicircle. So if this little piece right here is 80, then that means BC must be 100 because it's a semicircle. It's got to add up to 180. So we wound up circling all of them. Look at that. Okay, number 11. Find the value of x, then find the measures of angles E and angle C. So what we talked about, when you have a quadrilateral inscribed in a circle, the opposite angles are supplementary. So that's what's happening here. So when I say the opposite angles are supplementary, I'm talking about, for example, angles B and D. All right, those are supplementary, which means they must add up to 180. So 9x minus 12 plus 7x must equal 180. Like terms are on the same side of the equation. We have the 9x and the 7x. So that's going to make 16x, bring down the minus 12, is equal to 180. Let's go ahead and add 12 to both sides. So that's going to be 16x is equal to 192. And then we will divide by 16 on both sides. A nice whole number. So x is 12. Now the measure of angle E, okay, so the measure of angle E is going to be 6x, so that's 6 times 12. All right, so that's going to be 72. And furthermore, if angle E is 72, that is opposite angles with angle C. So the 72 and angle C, those are supplementary. They have to add up to 180. So that means if I do 180 minus 72, that should give me the measure of angle C. So that's why it's going to be 108 degrees. Number 12. Find the value of x, then find the requested measures. Well, look at the situation that we're in. We've got an angle that is on the circle. That means that the angle is the arc divided by 2. Okay, that's like the formula that we have. So the angle is 4x plus 8. The arc is 10x minus 22. Okay, the angle is equal to the arc divided by 2. Now, I have a choice. I could either, I could multiply both sides by 2 right now. If I do that, I have to remember to distribute. Okay, maybe I'll do it this way first. So if I multiply by 2, that way those would cancel each other out, so I'm doubling this. In fact, some kids would have started with this equation. They know that the arc is twice as big as the angle. So if we double the angle, it should equal the arc. That's a way to think about it. Anyway, that's going to give me 8x plus 16 is equal to 10x minus 22. I will now subtract 8x from both sides to kind of pull these together, get those variables together. So that's going to give me 2x minus 22. And then I would add 22 to both sides. So that's going to give me 38 is equal to 2x. And then, so if you divide both sides by 2, that's going to be 19. Okay, now a slightly different way I could have done it. Because it just so happened that both of these are divisible by 2, instead of multiplying both sides by 2, I could have done the following. I could have divided both of these by 2. So that would give me 5x minus 11. Okay, and then I would have subtracted 4x from both sides, and then I would have had 8 is equal to x minus 11, and then I would have added 11 to both sides, and I would have gotten 19 is equal to x. All right, so I mean, you're going to get the same thing either way. So now that we have that, we can go back and find other stuff. So they asked us to find the measure of arc EC. Okay, that's this guy up here. I feel like I need to erase some of this. You know what, I'll squeeze it in. In fact, I'll write really small. So the measure of arc EC, which I'll put over here, we know that to be 10x minus 22. Now we know that x is 19, so that makes it 10 times 19 minus 22. $168. Okay, now how about the measure of arc DC? Well, I don't have to do any calculations like that again. Now that I know that this arc is 168, and I know this arc over here, all right, so I've got the 168 happening right there, and I've also got this arc given to me, arc ED is 142. Well, everybody, that leaves only this arc remaining. So since I have the rest of the entire circle, except for the purple, I should be able to subtract from 360. So if I do 360 minus the 168 and minus the 142, boom, 50. Okay, that means this must be 50. All right, now they all add up to 360 as they should. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.